So basic idea for today is getting to creating this assembly. This is just from SolidWorks CSWA, which is like the SolidWorks training course. You take it if you do Intro to CAD, like the class. So you don't have to pay like $90 to take it, but good thing to go on your resume. I don't know that it's worth the cost of taking a class, but it's there for you. So how they do it in the quiz is they say like you have 15 minutes or whatever it is to make this assembly. And then like there are certain dimensions associated with it that then you figure out what the center of mass is and everything. But today we'll just be going through how to actually make it, some of the ways that assemblies work. So to make an assembly, all you have to do is go up to New, and this dialog will pop up. It might look like this, in which case you can click Assembly or just change it back to Novice, but click on Assembly and say OK. And it'll bring up this little sidebar, which lets you put in parts that you already have open. So right now I just have that completed file open, so that's all that shows up. I could introduce that into another assembly, but we're not going to do that. We're just going to X out of that. And assemblies are, same kind of thing as regular parts. So you have your assembly window, or toolbar, which is equivalent to your features toolbar. You also have sketches, because you can do sketches in assemblies as well. But yeah, so the basic workflow of an assembly is you take a part. So come over here and click Insert Components. And then if you just click Browse, you can go to wherever you have your parts stored. And we're going to open up Linkage Base first. And that'll just be, so when you open up a part, you'll be able to drag it around the window. And if you want, you could just click and place it somewhere. Interesting. Usually when you click and place it, it'll be undefined, which will be marked by the same thing as an undefined sketch with the little minus sign, which means basically you can move it around. It's not constrained in any way. So really what you want to do for the first component you want to insert is fix it in place. So that's part of the kind of workflow of working on an assembly, is figuring out how to build it up. For this case, we have these 5 parts. And if we look at the assembly we're trying to make, let's back out here. Look at the assembly we're trying to make. We can see the yellow part is fixed, so it doesn't move. Like this bar could, in this mechanism, could theoretically move back and forth, which will cause these guys to spin and move up and down. So the red bar always stays in place. So we're going to use that as like the base that we build up our entire assembly off of. So you go to Insert Components again, and we'll just select the linkage base. And what you do, if you just click the OK button, then it will automatically fix the part in place, so denoted by the little F here. And it will align it so that the front plane of the part is aligned with the front plane of the assembly, top plane is aligned with the top plane of the assembly, etc. So this part obviously cannot be dragged around. It's in a known location. So it's always important when you're making an assembly to have a good base for it. So like for our rockets, the base, or the first part we insert that's fixed, is usually like the body tube, because all the other components attach to that. And for the most part, it's not moving, particularly relative to the components that are inside of it. So yeah, once you have your first part, then to actually do anything.
It won't let me add the part. Like it's saying it's like incompatible or something.
Oh, is it something about the version number?
I don't know.
Do you want to share your screen and I can look at it?
Sure.
Yeah, I think these might have been saved as like SolidWorks 2019, so they might have some issues opening in 2020.
Sorry, I can't find the share screen option.
Oh yeah, it should be right next to the leave button. It's like a little box with an arrow in it. Let me make sure you have permission.
My like SolidWorks window doesn't show up as an option to share. Like it'll let me share all my other windows, but not SolidWorks for some reason. I don't know why.
Interesting. Can you just share your screen instead of a window?
I can try.
I don't know if you're on just a single monitor, it should just show up as one under screen. Yeah, there you go. Okay, so
Yeah, like that's what it keeps doing.
Do you want to try and just open the part normally? And we'll see if that even works.
Sure.
Oh, it's because you have to unzip the folder first.
Oh, okay. How do I?
So in that SolidWorks window, you can do it, or you can do it there. Just go to like your downloads folder or whatever it's located. Right click it and hit unzip. You didn't highlight it, so right click on it again. Yeah. Or extractor. Yeah, extract all, fourth one down.
Okay, thank you.
Yeah, so now you can open that folder and it'll have the parts in there. So if you back out to downloads, still in the open window, yeah. Cool. I will take over sharing again. So
Thank
yeah,
you.
yeah, no problem. So once we have this first part in, obviously it's an assembly, so there's not much you can do with one part. So we'll add our next one. Same process as before. In this case, I think let's just add the linkage cylinder. So theoretically, again, you could press the OK button and it would snap to the origin of the assembly, but we want this to have a fixed location on the part we currently have, so we'll just click anywhere in the command window. Now you can see this one has a little minus sign on it, free to move around. So we want to constrain it. And the way we do that is by hitting the mate button right next to the insert components button. And basically what mate does, and that's really pretty much the only two buttons you need to know to make pretty much any assembly. Like you can do patterns and stuff, but at the end of the day, you could accomplish the same thing by putting in multiple parts. So a mate will take the geometry of one part and attach it to another in a couple of different ways. So the standard mates that they have options for are coincident. So if you have a flat face here, I can click on two flat faces and they just line up on each other. So if I make this constraint, you can click the checkbox here, or you can click the checkbox up there. Now, this part is still not constrained. If I were to open this up, you can still see it as a negative because it can move around all like this. But if you look at it from this direction, you'll see it doesn't actually. If you look at it from actual side on, it can't actually move in this direction. So that is one constraint. Usually things will have 3 to 6 degrees of freedom depending on what they are, so you have to constrain all of them. Right now we have constrained 1 degree of freedom. Other options, so let's just get rid of that one. We also have parallel mate. So if I apply that between the same two faces, initially it kind of looks like it does the same thing, but we can actually still move this in pretty much any orientation. We just can't rotate it this way or the other way, because now these two faces are parallel, as the name suggests. Perpendicular, same kind of thing. I could select the same two faces, now they're perpendicular. This is still free to move, translate in all three axes, but it's now constrained rotationally in two, I suppose, out of the three. Tangent will work on circular faces. So let's say for whatever reason I wanted this circle to ride on this flat face. Now this is constrained against that face. The same kind of thing as coincident, but it's still free to rotate just as long as that face remains tangent to the part, the base part. Let's get rid of all these. That's left. Concentric is the other one. And concentric is, as the name suggests, if you have two circles. So let's select that circle and this one, then it makes them lined up, having the same center, concentric. So those are the standard mates and pretty much all I need to do to build up any arbitrary assembly. So in this case, let's look at what we want to do with this part. We want the green piston cylinder to mate up against the face of the base plate, and we want it to be constrained through that hole. So we'll select one of the faces of the bottom part of the piston, or the cylinder there, and bring it up against the base plate. Hit OK. And then we'll select the inside circle of the cylinder and this bolting hole location. And now we can see they're all lined up. So that accomplishes what we want to for this part. You can see it's still not actually constrained because it is able to rotate in one axis, but that's fine because some of the other parts will constrain this to be flat like it is. Something that's important that you want to make sure you're doing in an assembly is not adding mates that don't actually exist in real life if you can help them. So we've kind of done it here. So obviously, as these two parts stand, there's nothing keeping these holes aligned, nor keeping this face together, but we'll add the bolt later. Sorry, one sec. So yeah, so we can get to adding some more parts. Same process, go up, insert component. Now we can actually add one of the bolts. How about? And we're actually going to end up needing 3 of these. So theoretically, you go back in, insert components, browse for it, and open it up again. Or you can just select the part in the feature tree, press Control-C, press Control-V, do it twice, and we get the 3 bolts that we need. You can see they're all numbered here, so you can keep track of that if you need to. But so this bolt, one of them is going to go through the cylinder into the base plate. So let's do that. Again, we're going to go to Mate. We're going to select the round surface of the bolt, and we'll select one of the faces there. And we'll make a concentric mate. So one of the good things that SolidWorks will do for you is it will guess what mate you want to make. So in this case, I selected 2 circular faces, so it was like, okay, he probably wants to make a concentric. If you select 2 flat faces, it will probably default to coincident. If for whatever reason the flat faces are like already perpendicular, it might default to that. It really just depends, but usually it makes your life easier, but it is something to keep out with, to make keep a lookout for it, to make sure that you don't have the wrong mate. But we have concentric here. The other option that you get with concentric is to be able to lock the rotation of your parts. So right now, or if I turn it off, you can see I can just turn this bolt however I want. If I lock the rotation, then you can see it's locked with the face that I applied the concentric constraint to. So I can spin this and they will both spin. For the most part, it doesn't really matter whether you block your rotation, particularly for like bolts and stuff, but it does make it so that your parts will be fully defined once you finish making all your constraints. So if you don't do it, then you might see a part as not defined and you'll think, okay, I just didn't apply the lock rotation constraint, but actually there's something else with the part that's wrong that you've missed. So usually good practice to apply it when it's applicable. So we'll hit OK there. This is now locked in the shaft, but it can still move back and forth. So we'll apply a coincident constraint between these two faces. And there we go. Now, so it's still undefined, but it's only undefined in the rotation axis, which is linked with this part. So still all good. Why don't we fix that and insert another component? And we'll do the piston. Again, just kind of open it up, click it wherever you want. The piston, same process basically. So that's the side that's going to go in the cylinder. So you can select the outside of that, select the face. We won't lock rotation because the rotation is determined by how this face mates with the base. So you don't want to mess that up. That's good. The other thing we can do, and the way that this is done in the CSWA, is apply a distance mate. So that's one of the other standard mates that's available. Similar to coincident, but it just sets a offset. So in this case, I can select the face of this piston and then rotate it around and look to the bottom of the cylinder and select both of those. And now if I were to do a cutaway, you'd see that the face of the piston is in there, face of the cylinder is right there, 1 inch separates them. And last but not least.
Wait, sorry, how did you do the mate between like the piston and the whatever the green thing is?
Yeah, the cylinder, the distance mate.
Yeah.
So it's in the same standard mates one. It's just has like a little box next to it instead of saying distance. So you can change what the distance is, but you can select this front face of the piston and then rotate around to see the bottom of the cylinder and select the face in there. I think you could also what the method is to select things through other objects in SolidWorks, but there's some way to do it where you like hold control or something too, and then you would hover your cursor over and it would recognize that you're looking for this hidden face, but for the most part you can just kind of rotate your view.
Okay, thank you.
So in the spirit of looking at some more interesting mates, then we can also look at doing this mate correctly. So one way to apply this mate, we'll put one of these bolts in the piston. So again, you can just kind of select the two faces. We'll lock rotation because this isn't going to be rotating at all. And we'll make these two faces together again. So what we want, I'll back out of the mate here just so I can see it, is for this piston to be rotationally, or basically we want this bolt to be in this slot. So one way to do that would be to apply a tangent mate. So the circular face of this bolt is tangent to the top and or bottom face of the slot. So you can see right now, as I had it lined up so that the bolt actually goes through the material instead of through the slot. You can change that by just flipping the mate alignment. That way it just changes which side of the face is tangent, and you get the same option for like coincident and stuff. But I can make a tangent mate like that, and that's fine. It constrains it. So let me press this distance mate so I can move it. So obviously it's not rotating at all, like around the shaft in any ways, but you can see it is going through the shaft, or sorry, through the base at the ends of the slots because we haven't told it don't go that far. So another way to do this, and if you haven't seen it, there's a mates little drop down that shows up at the bottom where you can look at all the mates that you've made. Another way to do this is if you go into mechanical mates, there's an option for a slot. And that just lets you select the face of a slot, and you can see it auto selects that entire slot geometry for me and the circular face of whatever pin is going in the slot. Hit OK on that. Now you can see I can drag this back and forth and it bottoms out at the ends of the slot. So that's a little bit more nicely constrained. The other thing it does for you is, let's say we actually had some tolerance modeled into the slot, so the diameter of the bolt was not the same as the thickness of the slot. If you were to do a tangent mate, then your bolt would be slightly offset one way or the other, depending on which face you mated it to. This way, it keeps it all nice and centered. So for the most part, it shouldn't matter. If you've designed your assembly correctly, you need to account for that tolerance. So putting that mate in shouldn't matter, but just to keep it all looking nice. And we'll enable this distance mate. So now we can see everything that we've defined is now fully defined, so it doesn't have the minus there. Because now this was previously able to rotate around this pin, and now because this has to be in the slot and the piston has to be concentric, it all has to be horizontal. So that's pretty much it as far as interesting mates go. We can go in and add our two link arms. And again, we'll just hit Control-C, Control-V on those. I don't actually know how precisely they did it on which side. So the internal link is connected at the piston. So again, we'll just do a concentric mate. We'll leave the rotation unlocked because we want this to be able to turn. And we'll do a coincident mate with the internal face of this and the face of the base. So that way they stay nice and together. So now obviously this can move. We'll do the same thing with this other pin on the other side. So another concentric mate. And then this one, you can mate the face of this link to the face of the other link. And that way, these are now nicely together. Last thing we need to do is add a concentric mate between the two central holes. So we can do that. You can do it with the geometry, or you can do it with the bolt and then apply two concentric mates. So we can lock rotation of one or the other, but once you do that, you can try this out of the way so I can actually access it. But now this is a slightly better way of constraining these two parts because in real life, the bolt has to be there. So if there was going to be like a misalignment with the bolt for whatever reason in your CAD, you're off by a couple millimeters one way or the other, the link would fail and you'd know that something's gone wrong. And we can finish it out by just mating the face of the bolt to the face of the link. So yeah, that's pretty much all there is to assemblies. You can see, like, if I suppress this distance link or a distance mate, then I can move this back and forth. Kind of freaks out towards the extremities, but if you keep it in a reasonable distance, it looks pretty good. So again, like I said, most of the art with making an assembly is just building it up in a way that makes logical sense. So like theoretically, I could have started by mating these two links together and then putting the bolt in and then adding the base and the piston and everything. But if you think about it from an assembly, like a mechanical assembly standpoint, is usually helpful. Like, how does this part go together? That's probably also how you want to make the assembly in CAD. It's also a good way to validate that your parts are actually assemblable, which is not always the case. So yeah, there are a couple of more advanced mates we can quickly talk about. So I'll get rid of this distance mate entirely, actually. We can go back up to mates in the advanced mates tab. A common one is, so in standard mates, we have our distance and our angle. So angle is the same kind of function as distance. And let's say I wanted these to be at a 30-degree angle or whatever, it would make that happen. But those are just static values. So it's really good for fixing the parts in place. But let's say I have an assembly like this where I want it to be able to move when I drag it. Well, I don't want to leave this open because now this can move pretty much wherever through all these components. But I don't want to, and it's all undefined, obviously, but I don't want to just lock it in a single position. So if you open up the Advanced Mates tab, you'll get options for limit distance and limit angle. So if you click on those, same kind of thing, you can still set like a nominal distance. But what it actually allows you to do, which is more interesting, is set a minimum and a maximum value. So let's again select the face of the piston and the internal face of the cylinder. And we can come over here, hover over that, that's the minimum value. So these can touch, theoretically. So we can set that minimum value to 0. Maximum value, I don't know exactly how long this part is, but I don't know, 2-3 inches maybe. More than that, 5 inches. That looks pretty good. So yeah, so this is just the actual distance that the part is at when you make the mate. So I can change this to anything between the minimum and the maximum value. It doesn't really matter. But once you make that, now you can see everything is defined. Nothing is undefined or able to move around, but I'm able to drag this back and forth. So for instance, this is what we did with the air brakes on our last year rocket. We set a angle limit for plus or minus 90 degrees on the actuator plate, and that was the full travel of the air brake. So we could just rotate that to turn it in and out. Yeah, that's pretty much all the common mates you'll use. I guess the one other more thing that you might encounter. So like how I said with the slot mate makes the pin that's in the slot in the center. There's also a use case for doing that with other parts. I don't know that there's a good option here, but let's delete something. Let's delete the mate between these two faces here. And when you look in the feature tree, it'll highlight the faces that are mated together. So that's helpful in identifying them. So yeah, let's say this part was actually, yeah, rather than doing that, sorry. If I make back, we'll do this linkage bolt. So this linkage bolt, let's say it was actually a reasonable size and not just the copy from these. And this was say like 1 millimeter longer than the distance between these two faces, which are not back constrained. Sorry, one sec. I wouldn't want to necessarily just mate the one face of the bolt to the one face of the link like we had, because then there's all this excess on the other side. Really, it's supposed to be in the center. So what you can do is if you go up to mate, again, in advanced mate, there is a symmetric constraint. So we select our symmetry plane as this blue one. So we could just select the middle of this coupler link. And then we'll select two faces that should be symmetric for it. So we can select the one side of the bolt and the other side of the bolt. And now we can hit OK. And now this bolt is constrained within or in the middle of these two parts. Obviously, it looks weird in this case, but again, imagine that this was a much shorter bolt. Then that would make a lot more sense than having it stick out on one side. But yeah, that's pretty much all I need to know for assemblies. That will be able to get you up and running with pretty much any assembly that you actually try and make. Like I referenced, there you can do patterns, which are exactly the same as feature patterns. Just instead of features, fillets, or extrudes, or whatever you would pattern, you can select components. So do a linear pattern of one of these links, and we'll bring it along this line, however many inches. Oh, that's very interesting. I don't know why that didn't work. Yeah, I only had one component. Yeah, so select two components if you want to actually pattern anything, but you could do that. We use that more often with the rocket, with a circular component pattern. So why don't I actually open up something in the rocket? We can look at the lower airframe assembly. So this one, after it loads because of all the bolts in it, you can see I have a whole bunch of mirrors and circular patterns. So if I roll this back, I made a plane for the middle of the fin because we want to mirror these. Also, first off, we want to mirror these links across the fin. So that's one. And we want to mirror them to the top of the fin. And then I think this was just, yeah, adding some extra bolts. And then we can pattern all this whole fin plus these radial brackets all around the assembly in one go. So instead of having to have 4 fins like we had with these sort of like 3 linkage bolts or whatever, it just shows up as a single one, has a single fin, for instance, and all of the rest of the fins are contained within this pattern feature. So much cleaner assemblies this way, and it saves you time as far as constraining everything. Cool, that's pretty much all I wanted to cover on assemblies. So I'll stop the recording.